put that on the thing here. So exam 2 next week, Wednesday and Thursday. Wednesday what? What date is that? The 4th? October 4th and October 5th will be exam 2. We need a little more time on 5.3, 5.4. All right, let's get going. So here we are looking at this. This is basically an XY table, isn't it? Right here, let me just get this out of the way. Wednesday, Thursday, October 4th, 5th. Okay, this is an XY table. F of X is Y. And they want us to figure out if that XY table is making an exponential function or a linear function or neither. How do you know? Basically, now you know if something's linear, right? If it's linear, then the y values add or subtract the same number. If it's exponential, which this is what this section's all about, 5.3 and then 5.4, the last two sections we have to do are whoppers. I was looking them over ahead of time last Thursday, I think it was, and especially 5.4. It's a mammoth section. That's why I wanted to give us an extra day. So I'm going to do what I can. Today and tomorrow, 5.3. Wednesday, Thursday, 5.4. Really big. These are the ones that are hard for people on the exam we take next week. So it's all about exponential, and 5.4 is logs. So exponentials, which is inverse exponential. So exponential and logs. So exponential. So the y values multiply or divide. Instead of add, subtract, they multiply or divide. Same number each time. So let's take a look at these y values. 3 to 5, that's add 2. And now it's add 5. So it's not linear. It's not adding the same number every time. You with me? That's adding a different number. If the y from y value to y value to y value, it's got to be adding the same number every time. So it's not linear. Or is it multiplying the same number every time? No, clearly not. It's neither. This one's neither. Let's move on to the next one. Neither linear nor exponential. Onward. So number 2, what's happening y value to y value here? Let's just, I'm going to skip that fraction. 1 to 3, that's add 2, but then that doesn't add to the next one. So it's not adding. What is it? Yeah, everybody see it's times 3, times 3, times 3. Even 1/3 times 3. Yeah, it's exponential, isn't it? I'm kind of running out of room here. It's exponential because it's multiplying by 3 each time. It's exponential. Everybody seeing that? The y values are multiplying the same number every time. So it's an exponential function. Okay, so but then the other thing is they want us to come up with the equation if it's exponential. So how do I do that? Well, it's going to be y equals a times b to the x. That's the general form of exponential. Notice x is in the power zone. That's what it means to be exponential. X is in the power zone. In other words, x cubed is not exponential. Because x isn't, it has powers, but x itself is not in the power zone. Everybody see the difference? So, x in the power zone is the very definition of what it means to be, well, the word's right there. I'll just underline it. Exponential. It means x itself has climbed up into power. Does that make sense? X itself is in the power zone. So this is a general exponential function. Okay, great. How do I find the a and the b? The a is the number, is the y number next to x equals 0. So what's next to x equals 0? On this one, 1. So it's 1 times, and the b, that's the number you're multiplying every time. 3 to the x. There's our exponential function. 1 times 3 to the x. And you can just say 3 to the x. That 1's not doing anything. We're done. Am I going too fast? You tracking with me? So when you know it's exponential, you want to put this in your 3x5 card for the exam next Wednesday, Thursday. So that means Monday, Tuesday we'll be doing the practice exam. Monday we'll take it. Tuesday we'll go over it. Wednesday and Thursday the real exam. So a times b to the x. Again, the a is going to be the number next to the 0 in the table. And the b is whatever you're multiplying by every time. That's the base. So there it is, 1 times 3 to the x. Or really, you could just say 3 to the x. Huh? That 1's not doing anything. Is that good? Does that make sense? Is that true? We're saying that this equation, let me go back here and erase this. We're saying that this equation, right here, this f of x, this y, is 3 to the x. Yeah, try it out. Put in a 0 for x. What do you get? What's 3 to the 0? 1. Anything to the 0 power is 1. Do you remember that from algebra? So sure enough, it's 1. Well, what's 3 to the 1?
3.
Well, sure, it's 3. What's 3 to the 2? 9. What's 3 to the 3? 27, yeah. That's right. That's exactly the function producing those values, isn't it? Does that work for 1/3? What's 3 to the negative 1? Yeah, remember negative powers flip things? Do you remember that? So that's 1/3. That's true. That's right. That'll be an important part of the section. You guys all remember that? Negative powers flip it, don't they? Negatives in the power zone do not make the number negative in the front, do they? They flip the thing. Remember that? Negative powers flip things. It's totally different than negatives in the front. It's not. It's not that. So what would be 3 to the minus 2? It'd flip it, and 3 squared is 9. But it's not negative 1/9. It's just positive 1/9. Negative powers flip it. And then you just do the power. 3 squared is 9. Remember all that? Sort of?
We get to use our that one card, right? Flash card.
Yeah, 3x5 card. Yep. All right. All right, let me give you a second. Try that one. Use your calculator or whatever you want. Figure out if that, what are the y values doing? Figure it out in your own. Are they multiplying the same number every time? Are they adding the same number every time? Are they doing neither? If the fraction confuses you, then skip it. Just start here at the 7. 7 times 6 would be 42. But does that work for the next one? Try it in your calculator. 42 times 6, is it 252?
Yeah.
So it's working. And it actually works for this one also. Times 6, we'll cancel the 6. Yeah, it's 7. It's working. They're multiplying by 6 every time, aren't they? So then it's what? Y equals a times 6 to the x. The b is 6. The base that has the x on it is the number you're multiplying by every time. So what's the a then? It's whatever number's next to 0. 7. 7 times 6 to the x. There it is. That's the x. So it's exponential. Whoops, they moved them around on me. Exponential, and it's 7 times 6 to the x. Is that good? Is that why is the a the number in the front? Let's see it do its magic right here. If you plug in 0, if you take y equals 7 times 6 to the x, and you plug in 0 here, you get 7 times 6 to the 0. And anything to the 0 power is 1. So y is 7. So you just get that number there. See, that's why that number there is automatically whatever's in front. Because the other thing to the 0 power just becomes 1 and vanishes. So that's why the a is whatever's next to x equals 0. Good? All right, give it a try. Find out if it's adding or multiplying the same number every time. What's it doing? Adding 4 every time. So what is it then? It's linear, right? If you just add the same number of times, that's linear. And so now what do you mean by linear? Like mx plus b kind of linear. Like a line equation. And do you see what that number you're adding every time is the slope? That's what that is, right? If we graph this, that means over 1, well, over 0 up 6, 4, 5, 6. It's just getting too big. Over 1 up 10, over 0 up 6, over 1 up 10. See, that means the rise, it goes up 4 over 1. That's what that means. That's the slope. See, that's the slope. So right there, that m is the number added each time, plus, good so far? So just like with the exponential equation, we have 2 things we have to find. With the exponential, we had to find a and b. With the linear, we have to find m and b. So the m, the slope, is whatever number's being added every time. That is what the slope is doing, right? When x goes up by 1, what does y go up by? Right, that's slope. So now what's the b? Whatever's next to 0, just like for the other one. Right, because when you put in 0 for x, y is just going to equal the number at the back, right?
I can have it b plus mx, right? Same thing.
Yeah, same thing. Y number next to x is 0 in the table. So there we go. It's linear, and there's the equation. 4x plus 6. You can check it out. You know, if you're ever unsure, just go back and try it out. Does it work? Does y equals 4x plus 6 produce these values? If I say this is 4x plus 6, does that work? If you put in negative 1, 4 times negative 1 plus 6, yeah, that's 2. 4 times 0 plus 6, yeah, that's 6. 4 times 1 plus 6, yeah, that's 10. 4 times 2 plus 6, yeah, that's 14. See how it's working? It's cranking out those values. It is indeed 4x plus 6. Good? So look at a table, linear, exponential. We looked at tables, now we look at graphs, and we'll look at equations. It's all about exponentials. Okay, so which one of those is the right graph? Well, I haven't told you anything about exponential graphs yet. Let me help. So the basic exponential graph, it is like this. Let me make it a plus, well, here, let me do it this way. A to the x plus b. Now, I realize I'm kind of changing the format now. A minute ago, I gave you the number multiplied in the front. And maybe it would help you if I did that again. Let me, yeah, I hope I'm not confusing you. So in case I am, I could just write it this way. How about that? Yeah, so let's just call it that. So that way, this is what I gave you a minute ago, right? 8 times. You realize you can move all those letters around. They're just placeholders. They're just names. You could call it Joe times Bill to the x plus Tom. You know, whatever. They're just names. You can move them all around. Don't get hung up on the names. It just means, you know, something in the front times something with an X on it and then something added. You know, that's all that means. So you'll see different teachers, different books. They'll change the letters. Don't let that bug you. It's the basic format that matters, right? Something multiplied, something with an X power on it, something added. That's what matters, is the position and what's around it. Anyway, so I'll just do it that way. So when you have that, the C right here, the thing added, so I'm calling it C, but you could call it whatever. The thing added, that's what matters. The thing added is a horizontal asymptote line. Put that on there first. So in other words, if somebody gives me y equals 7 to the x plus 2 or whatever, I'd go 1, 2, and I'd put a horizontal asymptote line at 2. So exponential graphs have a horizontal asymptote line, okay? And then whatever number is off to the, what's the a on this one? 1, right? 'Cause there's nothing there, so it's like there's a 1. That number is how far off of the horizontal for the center point. In other words, this is at 3 because it's 2 add 1. So whatever number a is, a is how far above the horizontal asymptote graph hits the y-axis. Can you read? I'm kind of messy in that writing. A is how far above the horizontal asymptote the graph hits the y-axis. So y is 1, it hits 1 above the horizontal asymptote line. And then what does it do from there? Generally, exponential graphs rocket up. They go up very, very fast because that x is in the power zone. You start plugging, 7 to the x plus 2. If you were to make like an xy table, y equals, and you put in like 1, it'd be 7 to the 1 plus 2 would just be 9. Put in 2, it'd be 7 squared plus 2. That's already 51. 7 to the second power is 49, Put in 3. 7 to the third is that 343? So 345 when you add 2. It's already at 345 just for 3. See how it's just rocketing up? It's already at 345 by 3. Put in 4, it's going to be like over 2,000. So it's just rocketing up. So they rocket up to the right. If the x is positive, normal. You know what happens if you make that x a negative x, right? You've seen enough about graphs. It'll turn it sideways, right? Negative x flips it horizontal, and it would go down like this, wouldn't it? For a negative x. Anyway, so there's the basic look. So I just want to give you the basic look of y equals a times b to the x plus c. Generally, exponential graphs have a horizontal at c. C equals 2. Horizontal. The a is how far above the horizontal, where the center point hits, and then the graph just goes up to the right like that. What's the 7 do? Well, the bigger that number is, the faster it goes up. But they all go up super fast, so it's not really a big deal. Like that. Okay. So with that in mind then, let's take a look at this graph that they've given. This one, first off, let me write y equals a times b to the x plus c. What's his horizontal? What's his c? Yeah, he's right at 0, y equals 0. So that's just 0. Okay, how far above the horizontal? What's the a above the horizontal? How far above the horizontal does it hit?
7.
It's like right here. Is that 7?
No.
2, 3, 4, 5. Yeah, it looks like 7, huh? It's like it's 7. So it's y equals 7 times b to the x plus 0. Everybody good so far? By just kind of looking at the graph, saying, okay, horizontal's at 0. It hits 7 above that. So 7's the a, the c is 0. Okay, now the b must be 7 because it looks like they're all 7s. Right? Oh, wait a minute. Am I doing the right thing? Well, anyway, let's keep going. What about the fact that instead of rocketing up to the right like this one does, this one goes up to the left, or no, as you go to the right, it goes down. So that means negative on what? On the x, because it's been flipped sideways. It's not a negative in the front here, because that would flip it down. We'll have some of those. That would be a graph that goes like that, right? If you put negative in the front, because that'd be a negative y effect. But we have flipped this graph sideways, right? It used to go this way. They flipped it sideways. That's negative x. So we're looking at 7 times b to the negative x plus 0. There's a negative x power. So let's go up here now and look for negative x powers. Now, I know there's some confusion about the 7 in the front, and what about the b, and those don't seem to have it. I'll address that in a minute. But let's take what we know and at least eliminate things from there. So it's got to be a negative x power. We agree on that? So it's not a. It's not c. The negative's not in the front. It's not e. It's not h. That doesn't have a negative x power. It's not f. That has a positive x power. So I just crossed off all the ones where the x is positive in the power rather than negative. It has to be negative. That's why the graph is flipped sideways. From the normal exponential, it's flipped sideways. Instead of going up to the right, they normally climb to the right. It's falling to the right. So it's been flipped sideways. We've got to have negative on the x. Okay, so now, could it be all, which one of these 4 that are left, three that are left, is correct? Well, it's a little bit tricky. It's not D, huh? Yeah, because see the D has the negative in the front there? The negative in the front right there would make it flip down, as I said. It's not that one. All right, we're down to 2. B and G, and they're very, very similar. It's not B, because if it was just 7 to the minus x, then it would be starting at 1. It's not starting at 1, it's starting up at 7. Right? Now, I know you might look at G and go, that's different. I'll explain. But we agree, it's not B. Because that would mean the A is 1. The A is 1, and it would be starting 1. The middle point, the start point would only be 1 unit above the horizontal. It's not. So by process of elimination, without full knowledge, we know it's G. Now, what about what we said about, this should probably be 7. The The b is 7, right? Because the base is 7. They're all base 7. So why isn't it matching up? Why is this the same as that? Yeah. Do you know that mathematically? Let me show you. So we're saying it should be this, because I told you the A is where it starts. It starts up at 7. The horizontal is 0. And the base for all of them be 7 to the negative x because it's flipped. Now, why is that the same? Well, think about what they've got. They've got 7 to the 1 minus x. Right? What is that? That's 7 to the 1 times 7 to the minus x. Remember you add powers? Do you remember that? Which is this? Let me explain a little bit. That might not have been enough explanation. Let me remind you of the powers. That's what's great about this chapter. Well, I don't know if it's great, but you need to remember all your power rules real well. I'm glad to review those, though. That's what I'm here for. So let me help you remember. Remember, like 2 to the 3rd times 2 to the 4th. Remember what powers do? Same basis multiply. What do powers do? They add. Remember, that's 2 to the 7th. So if I have 7 to the 1 times 7 to the minus x, they add 1 plus negative x, which is 1 minus x. See how? That's the same thing, and that's what we have there. It's a different way to say the same thing. That good? Starting to remember all those power. We're going to push hard on all those power rules, so I'll remind you as we go on through. Questions on that one? I like this multiple choice A through H. I was thinking about doing that for our next exam. Do you guys like that? No. I'm just kidding. I'm just joking. It'll just be A through E. All right, so try that one. Figure out what that one is. Obviously, the base is 4. They all have base 4, so just go with base 4. But it's been flipped and stuff. There's the horizontal 0, right? So try writing out the function. Has it been? It's certainly been flipped vertically. Has it also been flipped sideways? Yeah, both. I think it's been done both, hasn't it? Because the normal one goes like this. So if you just flip it vertical, it'll go like that. If you just flip it vertical. But it's also been flipped sideways, right? So, and by the flip, I mean we rotate about an axis. Remember, we grab the axis like a rotisserie, and we flip it, zoop, down here. And then they grab this, and they turn to this one, didn't they? They flipped this, and so now, I'm having trouble seeing that. What does it do? It's going to flip that sideways. Yeah, it's going to do this. Yeah, that's what it does. Yeah, they flipped it both sideways and vertically, didn't they? See, that's what's two. So there's negative on the x and negative in the front. Both. Negative in the front makes the vertical flip. Negative on the x makes the horizontal flip. You with me? So negative in the front and negative on the x. They flipped it sideways and flipped it vertically, haven't they? So it's not this one. That one only has one negative. Only one. Is that it? You guys got it already? Yeah, D is certainly a possibility. Not this one. He doesn't have negative on x. He doesn't have. Yeah, that was easy. All right, boom. Negative on both. Done. D. Good?
Thank you.
All right, so we'll keep moving. All right, try that one. You got a different horizontal, right? Negative 1. So you know the C is negative 1, huh? Good. The horizontal. Horizontal asymptotes, negative 1. Like that. Now you can put that negative 1 in the front or the back. I mean, notice you could write it this way. Negative 1 plus A times, that's the same thing, as you know, right? I don't know which way they did it, but it could. Just once you know, that's got to be a little flexible. They could move things around. The B is obviously 4. They're all base 4, so I'll just stick in the 4 right now. They're all base 4, all the options, so it's base 4. Okay. So what? Now what's the A? The A is how far above, bless you, how far above the horizontal thing hits. It hits right there. How far above the horizontal is that?
1.
That's up plus 1, so the A is 1. So it's like it's really not there. We got that. Now, has it been flipped sideways, vertically? What's it been? Normally they go up to the right. This one goes up to the right. It's normal. No flipping at all. So it must be that. 4 to the x, it's e, huh? There it is. It's not this one because that one has the 1 in the power zone. That's different. Good? Easy enough? Oh, there might be, huh? Okay, I guess we'll start here. Identify the graph. Y equals 4 to the x plus 2. So, okay, so you know the general, so here we would use what we generally know about exponential and then what we know about move-in, shift-in, and all that we learned before. We'll keep using that. So 4 to the x, what's the general look of 4 to the x? Well, 4 to the x, oh, I'm sorry, no, never mind. I'm not being very clear. What is that plus 2 going to do? That's the c, that's the horizontal aspect. You can see why now, huh? Really, I could have just said to you, hey guys, the general exponential has a horizontal at 0. And you already know. Any number out here added to the right is a y effector. He's not in the x zone. Move the whole graph, the whole thing, asymptote line, graph and all, up 2. So of course you're like, oh, of course, Mr. Heron. Of course that thing is up 2, huh? Of course that's where the horizontal asymptote. It's just a result of the fact that we moved the whole thing up 2, and they normally start at 0. So I guess I really just needed to tell you they normally start at 0. Do the shifts from there. The plus 2 shifts it up 2, of course. But it's good to also have it said straight out. So it's at up 2. So at a height of 2, that's our C. That's where the horizontal is. So, okay. And then what is the graph going to do? What's the A on this one? What's the number multiplied in front? Just a 1, so that's the A. So that means 1 above the horizontal. And then it's just positive x, so it's just going up to the right. No negatives anywhere. So there we go. Can you tell which one? B. Yeah, it's B, huh? Yeah, B. Now, see, it's recorded. All right, so what's the domain? Yeah, when you have a picture, it's just left and right. Domain is just left, right, with parentheses or whatever. So it's just negative infinity. But that graph goes forever left, forever up and right, huh? What's the range? Bottom, top, right? What's the bottom? Oh, 2. Yeah, 2. It never goes below 2. Parenthesis on the 2 because it never quite hits the 2. You never quite hit that asymptote line, huh? So bottom, top, 2 to infinity. The range is the vertical. And finally, what's the horizontal? Asymptote. That's y equals 2. Right, because this dotted line here hits the y-axis at 2. Y equals 2. A half is 2 to the negative 1. That's the trick. Do you realize that? 2 to the negative 1 power is a half. This is the game they're going to play in this chapter. Is they're going to really push your knowledge of the fact, especially like negative powers, what they do, they flip things. So you want to just always think that way. If you're looking at a fraction, you want to think, oh, that's a negative power. That's what negative powers do. They flip things. They don't make negatives in the front. They flip things. So negatives in the power zone are very different than negatives in the front. Two totally different things. Negatives in the power zone just flip things. So what am I saying? Well, I'm saying this function, y equals 4 times a half to the x. What you should really do to help yourself out is go, look, that half, is 2 to the minus 1 to the x. Or you can just make it 2 to the minus x. Same thing. You see that? This is that. Because that 2 is 2 to the minus 1 power. And then times the x, it's negative x. Everybody see that? So then we go, oh, okay. So what's the c? What's the c out here? 0. So it's got a horizontal asymptote at 0. This is my a, which is 4. So it hits 4 above. 4 above. Like that. And then what's that negative x going to do? That's going to sideways. So normally they go up to the right. This one will be flipped this way. Sideways, right? Like that. It'll look like that. So yeah, which one is it? D. Yeah, it looks like D, doesn't it? Everybody good with how we walked through that? So fractions are negative powers, aren't they? So that's the key. Okay, so we got y equals 5 to the x plus 2 minus 2. So the minus 2 is the horizontal. 1, 2. So minus 2 is the horizontal. What's the a? It's 1. So it means it hits 1 above that. Good there? Now, what does that x plus do? Remember what it does to a picture, a graph, when you add 2 to the x value? Left 2. Remember, x has an opposite effect. X is always right, left. Opposite. So this means left 2. What goes left 2? Everything. Easiest way, though, is to grab one kind of central point like a handle and move it left 2. So I'll grab this point and go 1, 2. Boom. He goes right there. And then the graph just does his normal thing. Because it's all positive x and everything else is positive. There's no negative multipliers anywhere. Does that make sense? That went left 2. So it looked like that. So yeah, it looks like B, huh? Yeah, because you got to go below. The other ones don't even go below. Well, A goes below, but wrong direction. Yeah, good. All right. What is E? It's a special number. That's all I'm going to say for now. 2.718. It goes on and on. 1828, 1828, and then it breaks away into a bunch of other numbers. Anyway, it's like pi. Pi is a 3-point whatever special number. E is a 2-point whatever special number. Now, in calculus, you'll learn more about E. E is what he is he's the exact number that's his own derivative. He's the special, perfect, exact number that is his own derivative. When you do derivatives in calculus, you'll see. So for now, I'll just say he's a special number, kind of like pi is. What's pi? What is pi? Yeah, it's the ratio of the diameter, pi. I don't want to. This isn't really in our thing here, but real quick. Diameter? No. Circumference to diameter. Because what's circumference? 2 pi r. What's diameter? 2 pi? No, not 2 pi. 2 r. Diameter's twice radius, right? What do you get? Pi. So in other words, ancient Egypt, way back then it started. They were finding circular things. They were measuring around them with whatever measuring tools they had, called the circumference, and they were measuring across the middle, called the diameter. Right? And they were dividing those numbers, and they kept getting a number close to 3.14. No matter how big the circle was, or small the circle was, a tree trunk, or whatever, they'd measure around it, measure across it, little circle, big circle, they'd divide those two numbers, they'd always get this 3.14, or close to it, depending on how accurate their measuring tools were. And then it became, over time, we realized that for any true circle, the ratio of circumference to diameter is pi, and pi, what just happened there? I hit some funny button. Probably looks fine on your screen, yeah. Anyway, pi is a number that is irrational, which means it actually goes on forever and ever and ever with no pattern. 3.141526 3.1415. Wait a minute, hold on. I know it a few places. I'm going to boast in my knowledge here. No, I'm going to show you. I know it, but I can't remember right now. 3.1415. It's gone. I'm getting too old. 3.14156. No, it's totally gone. Give me a couple more. 3.141. 3.141. 3.14159265535. Right? Yeah. Anyway, you know why I know that? I have a terrible memory. I remembered that standing in my calculus teacher's office hours, waiting my turn. That's why I bring that up. I went for help constantly, and he had pi around his office on the top, and like to 10,000 digits or 100 digits or whatever. And I would just stand there, my little notebook, waiting my turn while somebody else was getting help, and I would just look up there and I'd remember another digit. That means, and I have a terrible memory. Ask my poor wife. I don't even remember anything, and she has this perfect memory and remembers things we did 20 years ago, and I always kid her. It's like you're a widow already, honey. Your memories are your own. I always kid her. Anyway, I have a terrible memory, and so my point is, I went for lots of help. Go get help. I mean, it's a good idea. Anyway, getting way off track here. So pi is a special number. It's just the ratio of a circle to circumference to diameter of a circle. E is a special number. Okay, with all that was a long story to say, it's just a number. Don't be stressed about it in any way. When you look at E, just think, hey, it's like 2 something. So they're basically asking me, hey, 2 something. to the x minus 1. Well then, in fact, yeah, 2.7 basically to the x minus 1. So what's that going to do? Well, what's the number out here added or subtracted? 0. So that's my horizontal, 0. What's the number multiplied? 1 times 2.7 to the x minus 1. So 1, and it's all positive, so it's going to, and what is that minus 1 going to do? Right 1. It's because opposite, right 1. So jump to the right 1, and there you go. I mean, makes almost no difference at all, the fact that it's e. So that's what I really wanted you to see with all that talk. That e is just a special number. It's nothing magical at all. It's just a special number, 2-some. Good? So just do what you normally do for exponentials on that. Which one is that then? I don't know. Anyway. Okay, let's try this one. Okay, yeah. Okay, so how do we do that one? It says y equals 3 minus e to the minus x over 2. Let me rewrite that. I think it'll be helpful to you. So let's rewrite it like this. Negative e to the negative a half x plus 3. Like that. That's the same thing, huh? But it's just easier to see that plus 3 at the back instead of at the front, and to see real clearly that negative is on the e, and this x over 2 is really a negative half on the x, multiplying the x. Good to there? Okay, so what's that plus 3 going to do? Horizontal asymptote. Right, going to move everything up 3, so the horizontal asymptote comes up at 3. Right, 1, 2, 3. That's at 3. Good to there? Okay, what number is in front here? A, just 1. So, but it's negative 1. So it'll be right here, down 1. Instead of 1 above the horizontal, it's 1 below. And, not only that, we have both a negative on the x and a negative in the front. So the normal one that goes up like this is going to be moved down. It's going to be flipped down by that negative in the front, vertical flip. And this negative will make a sideways flip. So in the end, it'll actually go like this, won't it? Everybody see that? So this is the final, I'm erasing it. This is the final one right here. Right? Flip sideways and vertical. So there's, what about the half? Who cares? That's just going to crunch it a little. Or actually, x does the opposite. It's going to expand it a little bit sideways. No, it doesn't make a big difference. So there it is. Which one is that? Is it? Oh, yeah. It confused me at first. Yeah, but the 3's up here. You guys are right. Yeah, because I kept looking at the axis. Yeah, totally right. There it is on that one. We'll wrap here. So 2 to the minus x is 4. How do you solve that for x? What I'm going to suggest is you rewrite that 4 as 2 squared. Once the bases are the same, the powers must be equal. Right? Because if 2 to something is equaling 2 to something else, those powers must be the same, or 2 to one of them wouldn't equal 2 to the other. So then divided by negative 1, x is negative 2. So we're just starting the equations. That's what we'll go crazy on.